All right, everybody, buckle up because we are diving deep today, deep into the world of physics. But not just any physics, Nobel Prize-winning physics, the kind of discoveries that make you really wonder about the universe.
Yeah, the stuff that seems like it's straight out of science fiction sometimes.
Exactly. But the best part is, you don't need to be a rocket scientist to understand why this stuff is so cool.
It's true. These discoveries, they aren't just equations on a chalkboard. They really are the foundation of our modern world,
Uh,
even if we don't always realize it.
Right, and that's what we're going to explore today. We're counting down the top 10 Nobel Prize-winning physics breakthroughs, and we'll talk about how these discoveries, even ones from decades ago, are still shaping technology today. Speaking of shaping technology, let's start with something I bet you use every single day: LEDs.
Oh yeah, the LED. So ubiquitous. We almost forget how revolutionary they were.
Exactly. In 2014, Isamu Akasaki, Hiroshi Amano, and Shuji Nakamura won the Nobel Prize for creating the first efficient blue LED. And you might be thinking, okay, so what? Big deal, right? But think about it. Red and green LEDs have been around for ages. But without blue, you couldn't get white light.
You need all three to make white light. And it wasn't just about making brighter displays, although I have to say, those are pretty awesome. But this breakthrough, it was much bigger than that. It led to a massive shift towards energy-efficient lighting, and that impacts everything. Reducing greenhouse gas emissions, providing affordable lighting in developing countries, you name it.
It's amazing how such a small thing can have such a huge ripple effect, right? Speaking of ripples, our next Nobel Prize. This one takes us from tiny lights to the vastness of space, the detection of gravitational waves.
This one really fires up the imagination.
Right.
In 2017, Kip Thorne, Rainer Weiss, and Barry Barish won the Nobel Prize. And they won for proving something that Einstein himself predicted a whole century earlier. The universe vibrates. It vibrates with these incredibly faint ripples in spacetime.
I've heard it described as listening to the universe breathe.
It's a beautiful analogy, isn't it?
Yeah. And what's even crazier is that these waves, they're caused by some of the most violent events imaginable, like black holes colliding millions of light years away.
It really makes you feel small, doesn't it?
Yeah,
But also connected, in a
Yeah.
way, to these events of almost unimaginable power.
for sure. And you know what's even more amazing?
What's that?
This wasn't just a theoretical win. They had to build an incredibly complex detector.
Right, LIGO, the Laser Interferometer Gravitational Wave Observatory.
Yeah, LIGO. It had to be sensitive enough to pick up these tiny, tiny disturbances.
Disturbances that are smaller than the width of a proton.
That's mind-blowingly small. And they did it.
Amazing, isn't it? The dedication and ingenuity of these scientists.
It really makes you appreciate the power of human curiosity, right? That we can conceive of something like that and then actually build it. All right, so we've gone from the tiniest lights to the vastness of space. Now let's dive into the heart of matter with the discovery that's been called the God particle, the Higgs boson.
Ah, yes, the Higgs boson. It's not every day you get to talk about finding a particle so fundamental, a particle that helps explain why anything has mass.
In 2013, Peter Higgs and Francois Englert won the Nobel Prize, and they won it for predicting the existence of the Higgs field and its associated particle, the Higgs boson, back in the 1960s. But actually finding it, that took decades of research and some of the most complex scientific instruments ever built.
Yeah, the Large Hadron Collider. It's a marvel of engineering.
It really is. So for those of us who aren't particle physicists, can you give us a simple explanation of what the Higgs boson is?
Sure. Imagine the universe is like a giant pool filled with this invisible syrup. This syrup is the Higgs field. Now imagine different particles are like objects trying to move through this syrup. Some particles, like photons, they're streamlined, they zip right through. But other particles, they get bogged down by the syrup. That bogging down is what gives them mass.
Wow, that's a great analogy.
And it helps to explain why some particles are heavier than others.
That's so cool. So it's like the universe's way of deciding which particles get to be the stars of the show and which ones are kind of just background noise.
It's a good way of putting it.
But this discovery wasn't just about confirming what Higgs and Englert had predicted, right?
Right.
It opened up a whole new realm of questions for physicists to explore.
Exactly. It's like finding a new continent. There's a whole world out there to discover.
I love that analogy. Okay, so we've talked about LEDs, gravitational waves, and the Higgs boson. What other mind-blowing discoveries await us in the world of Nobel Prize-winning physics?
Well, for our next stop, we're going even deeper into the quantum world. And trust me, things are about to get really weird, even for physics.
I'm ready. Let's do it. I'm ready. Let's do it.
All right, we're talking about laser cooling and trapping of atoms.
Okay, already sounds pretty wild.
In 1997, Stephen Chu, Claude Comen-Tanucci and William D. Phillips. They won the Nobel Prize for figuring out essentially, how to freeze atoms in place using lasers.
Lasers that can stop atoms. That sounds like something straight out of Star Trek.
Right. But it's real, and it's every bit as amazing as it sounds.
So they're like holding these tiny atoms perfectly still with light.
Exactly.
That's incredible. But how is that even possible?
It's all about the momentum of light. See, light particles, photons, they carry momentum. And when they hit an atom, they can transfer that momentum. So by carefully aiming lasers at atoms from multiple directions, you can slow them down, cool them down,
Yeah.
and eventually trap them in place.
That's mind-blowing. But this isn't just some neat trick, is it?
Oh, definitely not.
So how does this freezing atoms thing affect our lives?
Well, one really cool application is atomic clocks.
Atomic clocks.
Yeah, they're the most accurate timekeepers we have.
More accurate than my phone.
Way more accurate. And they rely on laser-cooled atoms to work.
So my phone's GPS wouldn't be as accurate without this technology?
Not even close. GPS relies on incredibly precise timing signals from satellites. And those satellites, they use atomic clocks.
Wow, I had no idea.
And beyond GPS, laser cooling, it's really pushing the boundaries in all sorts of fields, like quantum computing.
Quantum computing. Okay, that's something I've been hearing a lot about lately.
It's a big deal. Imagine computers that are millions of times faster than what we have today.
Millions of times faster. What would you even do with that kind of power?
All sorts of things. We could develop new drugs and materials, break encryption codes, model complex systems like the brain. The possibilities are pretty much endless.
Okay, now we're talking about the future. But for now, let's get back to those Nobel Prizes. We've still got a lot of ground to cover.
Right, you are. And speaking of quantum mechanics, our next Nobel Prize goes even deeper into that weird and wonderful world.
Oh, I'm ready for more quantum weirdness.
All right, buckle up. In 2012, Serge Haroche and David J. Wineland, they won the Nobel Prize for, to put it simply, for figuring out how to manipulate individual quantum systems without destroying them.
Okay, I'll be honest. The quantum world still makes my head spin a bit.
Yeah, it's definitely not intuitive.
So, like, what even is a quantum system? Can you give me a simple example?
Sure. Think about a single photon. That's a quantum system. Or an electron spinning around an atom. That's another.
Okay, so, like, the tiniest particles imaginable.
Exactly. And what Haroche and Wineland did was develop these incredibly precise ways to isolate those particles and manipulate them to see how they behave.
So they were like quantum mechanics.
In a way, yes.
That's wild.
It really is.
And their work, it's important for those super fast quantum computers we were just talking about, right?
Absolutely. To build a quantum computer, you need to be able to control these individual quantum systems. And that's exactly what Haroche and Wineland's work allows us to do.
So their research is like laying the foundation for a whole new era of computing.
Exactly.
Incredible. It's amazing how these Nobel Prizes, they're for discoveries in physics, but they really do touch every aspect of our lives.
They do. And that brings us to our next Nobel Prize. This one's for a theory so fundamental to our understanding of the universe. It's hard to imagine modern physics without it.
Okay, I'm intrigued. What's this game-changing theory?
We're talking about quantum electrodynamics, or QED for short.
QED.
Yeah, it sounds intimidating, but it's actually quite elegant in a way.
So in a nutshell, what does QED actually explain?
In the simplest terms, it explains how light and matter interact.
Okay, that sounds pretty basic.
It is, in a sense,
Mm-hmm.
but the way QED explains it, it's incredibly precise, and it has led to some amazing technological advances.
Like what?
Well, for starters, our understanding of lasers, that's all thanks to QED.
Oh, wow.
And then there's magnetic resonance imaging, MRI.
MRI. You mean the thing they use to look inside your body?
Exactly. QED played a key role in developing that technology.
It's incredible how something so fundamental can have such far-reaching applications.
It really is.
And speaking of fundamental, our next Nobel Prize takes us back to the very birth of quantum theory.
Ah, yes, the beginning of the quantum revolution. In 1918, Max Planck, he won the Nobel Prize for discovery that shook the foundations of physics.
What was Planck working on that was so revolutionary?
At the time, physicists were struggling to understand a phenomenon called black body radiation.
Black body radiation?
Basically, it's the light emitted by an object when it's heated up.
Okay, I think I get that.
But the problem was classical physics. It couldn't explain the pattern of light that was being emitted.
So what was the answer?
Planck came up with a radical idea. He proposed that energy, instead of flowing continuously, was actually emitted in discrete packets, or quanta, as he called them.
Quanta. So instead of a smooth stream of energy, it's more like little bursts.
Exactly. And that idea, it completely revolutionized our understanding of light and energy.
And it laid the groundwork for the development of quantum mechanics, right?
Exactly. Planck's discovery of energy, quanta. So it was like opening up a whole new universe of possibilities.
And it's amazing to think that all of this, from lasers to MRI to quantum computers, it all stems from this fundamental idea that energy is quantized.
It's true. It's a testament to the power of a single groundbreaking idea.
Absolutely. Okay, so we've covered a lot of mind-blowing physics so far. What other amazing discoveries await us in the world of Nobel Prizes?
Well, up next, we have a discovery that's not just about understanding the universe, but also about harnessing its power in a way that directly shapes our digital world.
Okay, I'm always up for a good tech connection. What's this discovery all about?
We're talking about giant magnetoresistance, or GMR for short.
Giant magnetoresistance. Catchy name.
In 2007, Albert Ferret and Peter Grunberg, they won the Nobel Prize for this discovery. And it's not an exaggeration to say it revolutionized how we store and access data.
Okay, so giant magnetoresistance. What exactly is it?
Imagine you have a tiny sandwich with layers of magnetic materials,
Yeah.
and you pass a current through it. Now, depending on the direction of the magnetization in those layers, the electrical resistance of the sandwich changes dramatically.
So it's like a magnetic switch.
Kind of, but on a much, much smaller scale.
And how does that translate into storing data?
This discovery, this GMR effect, it led to the development of incredibly sensitive read heads in hard drives.
Read heads.
Yeah, the part of the hard drive that actually reads the data.
So if I can store thousands of songs on my phone, I have GMR to thank for that.
Exactly. GMR technology. It allows us to cram more and more data into smaller and smaller spaces.
Wow, that's pretty incredible.
It really is. And it's a perfect example of how fundamental physics research, it can lead to these unexpected but incredibly important technological advances.
It makes you appreciate the power of scientific curiosity, right?
Absolutely. And that brings us to our next Nobel Prize, which takes us on a journey into the heart of matter to explore the fundamental building blocks of the universe.
Ooh, I always love a good particle physics deep dive.
All right, then get ready, because in 1992, Georges Charpak won the Nobel Prize for an invention that revolutionized our ability to study the smallest particles in existence.
Okay, tell me more.
Charpak, he invented a new type of particle detector called the multi-wire proportional chamber.
Multi-wire proportional chamber.
Yeah, it's a mouthful.
What did this chamber actually do?
It allowed physicists to see the tracks of individual particles with incredible precision.
So before this, we couldn't really see these tiny particles.
Not very well. Imagine trying to study a rainstorm, but you can only do it by catching individual raindrops on your tongue.
That sounds inefficient.
To say the least. Charpak's invention, it was like giving physicists a high-speed camera, a camera that could capture the fleeting paths of these subatomic particles in stunning detail.
So it's like he gave us a new way to see the universe.
Exactly.
That's amazing. And you know what's even more amazing? We've saved the most iconic Nobel Prize for last.
Oh, I know where you're going with this.
We're talking about Albert Einstein.
The legend himself.
So which of his groundbreaking theories won him the Nobel Prize?
You might be surprised to learn that Einstein actually didn't win for his theory of relativity.
He didn't, but that's like his most famous work.
It is. But the Nobel Committee at the time, they were a bit wary of relativity. It was still quite controversial.
So what did Einstein win the Nobel Prize for?
He won it in 1921 for his explanation of the photoelectric effect.
The photoelectric effect. That doesn't sound quite as groundbreaking as relativity.
I know, it doesn't have the same ring to it, does it? But the photoelectric effect, it's actually incredibly important.
Okay, tell me more. What is it?
It all starts with a simple observation. When light shines on certain materials, it can knock electrons loose from the atoms, creating an electrical current.
Okay, that makes sense.
The problem was, classical physics, it couldn't explain why this happened.
And that's where Einstein comes in.
Exactly. Einstein, he proposed a radical solution.
What was it?
He said that light, which we usually think of as a wave, it can also act like a particle called a photon.
Light can be both a wave and a particle. Now that's a head-scratcher.
It is. But Einstein showed that this duality, it was the key to understanding the photoelectric effect.
So how does it work?
Basically, Einstein said that light, it's not just a continuous wave. It's also made up of these tiny packets of energy, these photons. And when a photon hits an atom in the material, it can transfer all of its energy to an electron, knocking it free and creating that electrical current.
Wow, that's fascinating. So light is like a wave and a particle, and this discovery, it won Einstein a Nobel Prize.
It did.
And not just that, but it also led to a whole bunch of new technologies, right?
Absolutely. The photoelectric effect. It's the foundation for things like digital cameras,
Hmm.
solar panels, even some medical imaging techniques.
Incredible. It's amazing to think how a discovery that might seem purely theoretical can end up having such a huge impact on our everyday lives.
That's the beauty of science, isn't it? You never know where a new discovery might lead.
And in the case of Einstein's photoelectric effect,
It led to a revolution in our understanding of light and a whole host of technologies that we rely on today.
it really makes you appreciate the power of a single groundbreaking idea.
It does. And, that's what all of these Nobel Prizes really highlight, the incredible power of human curiosity and ingenuity.
From the tiniest particles to the vastness of space, these discoveries have not only expanded our knowledge of the universe, but they've also shaped the world around us in profound ways. It really makes you think, what incredible breakthroughs are just around the corner.
I know, right? Like, what mysteries will future physicists unravel? What new wonders will they reveal?
And to think, all of that, it'll all build on the incredible work of these Nobel laureates, the tools they've given us, the knowledge,
It's like they've given us a map to the universe.
and it's up to us to keep exploring.
Exactly. To keep asking those big questions.
So as we wrap up our deep dive into the world of Nobel Prize-winning physics,
What do you think is the biggest takeaway?
for me, it's the power of human curiosity. This drive we have to understand the universe, even the parts that seem completely bizarre and counterintuitive.
It's true. These scientists, they dare to ask why.
Mm.
And in doing so, they didn't just expand our knowledge, they changed the world.
And sometimes those changes came from the most unexpected places.
Right. Like, who would have thought that manipulating atoms, that could lead to better GPS systems?
Or that understanding the quirks of quantum mechanics could pave the way for faster computers.
It just goes to show you never know where fundamental research might lead.
It's an investment in the future.
Absolutely.
So the next time you snap a photo on your phone,
Yeah.
or see a solar panel soaking up the sun's energy, or even just gaze up at the night sky, take a moment to appreciate the incredible discoveries in physics that made it all possible.
It's a good reminder that the universe is full of wonders. Wonders waiting to be uncovered.
And who knows, maybe someday, someone listening to this will be the one to make the next big breakthrough.
I like that thought.
To all you aspiring physicists out there, keep asking questions, keep exploring, and never lose your sense of wonder, because the universe is a vast and mysterious place, and there's still so much left to discover.